exponential functions have the amazing property that their rate of change is proportional to the original function. One way of writing this is the derivative of a to the x is proportional to the function a to the x. Proportional to means equals a constant times a to the x. Now by choosing the special constant e as the base, this constant of proportionality becomes 1. In other words, the derivative of e to the x is e to the x. Now let that amazing fact sink in. One way of saying what that means, that the derivative of e to the x is e to the x, is if you look at the graph of the function y equals e to the x, then y prime equals y. In other words, the height of this function is always equal to the slope. So where the height of the function is 2, the slope is 2. Where the height of the function is 1, the slope is 1. Where the height of the function is 1/2, the slope is 1/2. Pretty incredible. Now this formula for the derivative is rather straightforward. The derivative of e to the x is e to the x. Added difficulty comes from combining that fact with the chain rule. The derivative of e to a function u of x is itself e to the u of x times, from the chain rule, the derivative of the inside function. So let's practice several examples under that paradigm. Example 1. What if the function is a constant times x? Well, the derivative of e to the 4x is e to the 4x times 4 from the chain rule. Or you could write 4e to the 4x. Oftentimes, this just works with a minus 1. So the derivative of e to the minus x is e to the minus x times minus 1. Or you might prefer to write minus e to the minus x. Now what happens as the function gets a little more complicated? Let's compute the derivative of e to the minus x squared over 2. Now again, the derivative wants to be itself, e to the minus x squared over 2, but from the chain rule we have to multiply by the derivative of the inside function. The derivative of minus x squared over 2 is minus 2x over 2, or just minus x. Let's look at this one. Find the derivative of sine pi x times e to the minus 5x. Can you see that we have to combine here the product rule with the chain rule and the derivative of sine and exponential? Let's put it all together. So the derivative of the first is cosine pi x times pi times the second plus the first sine pi x times the derivative of the second, which we now know is minus 5e to the minus 5x. Finally, I'd like to remind you what happens when we don't have the special number e as our base. In general, with a number a as the base, the derivative of the exponential function a to the x is a to the x times the natural log of a. So a simple example of that is the derivative of 2 to the x is going to be 2 to the x times the natural log of 2.